In this video, we will see 3 examples of adding, subtracting, and multiplying with radicals. Let's take a look at example 1. Here we're asked to try to combine these 3 radicals by adding and subtracting. When adding and subtracting, the roots have to match, and currently none of them match. Before we say that there's nothing we can do and that we're just done, we should probably simplify these radicals to their simplest terms. Then we can decide if they match or don't match. Now this first one here just has the square root of x. There's not much we can do with that, so we're going to leave him be. But let's take a look at the second one. The second term here has the square root of 12. And that's something we can simplify. So I'm going to go out to the side here and just re-examine 5 root 12. Let's get it to its simplest form. So this means 5 times the square root, and instead of 12, we're going to simplify this by breaking him apart into 4 times 3. The reason we're doing that is we can do the square root of 4, it's a 2, but the 3 is going to have to stay under the radical. Now when this 2 comes out, this is 5 times the stuff in the root, so it's 5 times the 2, so this is now 10 root 3. So instead of 5 root 12, we're going to write 10 root 3. Let's see, this first guy we're not changing. We're going to change this to 10 root 3. Now let's look at this third term, the square root of 9x. That's another one that can be simplified. So square root of 9x, well, the square root of 9 is just a regular 3, and we're going to keep the x in. So it would simplify into 3 root x. So back over here, we're going to put in 3 root x. Once we've done that, we can see that we actually have 2 pieces that have matching roots. And if they have matching roots, we can put them together. Since those have matching roots, let's see here, 6 root x and 3 root x. When we add them together, that gives us 9 of the root x's. Unfortunately, 10 root 3, not much we can do with that. So I think at this point, we are done. We cannot put those 2 together because this one is the square root of x, and this one is the square root of 3, and they don't match. Example 2 is a multiplication problem. Remember, squaring something means that thing times itself. So maybe it would help us to write this out. It means take all this stuff times itself. This is actually a FOIL problem, or you can use distributive properties, same thing. So the first thing we're going to do is 3 root 6 times 3 root 6. Now if that's a lot all at once, you could take it out to the side if it helps. Remember, order doesn't matter, so you could rearrange since it's all multiply to look like this. So this is really 9 root 36. Now, the square root of 36 we could simplify. It's a regular 6. So this is 9 times 6, or 54. So the first term of FOIL, when simplified, is going to be 54. Let's look at the next bit of FOIL, the outside. So 3 root 6 times, it's going to be negative, so I'm just going to put the negative in here so I don't have to worry about it over here, and 4 root 5x. Again, order doesn't matter. We're going to be able to do 3 times 4 and get 12. And under the root, 6 and 5x, when we multiply all that, is 30x. So this is minus 12 root 30x. Remember, when you're multiplying, stuff out of the root multiplies with stuff out of the root. Stuff under a root multiplies with stuff under a root. But no mixing and matching unless somebody's coming out of the root. So that's the outside of FOIL. The inside of FOIL, if you notice, is going to be the same thing. So minus 12 root 30x. The last in FOIL, so negative times a negative is positive. And we're going to need to do 4 root 5x times 4 root 5x. Well, the 4's are both outside of the root, so we can multiply those. And under the root, we're going to have 5x times 5x, or 25x squared, which is all things we can do the square root of. 16's regular 16, so we'll leave him there. The square root of 25 is 5, and the square root of x squared is x. Let's see, 16 times 5, that's going to be 80. So 80x is the L in FOIL. At this point, we've done all the multiplying. Now we're looking to see if there's any like terms we can put together. And I see that this guy has a root 30x, and this guy has a root 30x, so we can put those together. Unfortunately, this right here is a regular 54, and this is an 80x. Since he's got an x and he doesn't, we can't put those together. But let's go ahead and combine the middle two. So we're going to have 54. Let's see, negative 12 and negative 12 means negative 24 of those roots. And then 80x. At this point, we have put together everything that we can. There are no more like terms or like roots, so this is as simplified as it's going to get. Let's try one last problem. I know these numbers look kind of scary, but let's break this down a bit. First off, 33, there's not much that multiplies to 33 other than 3 and 11, and those aren't perfect squares, so I can't do anything with this as far as breaking down the roots. My guess, I have a sneaky suspicion that maybe 33 goes into this, because then that would make these kind of match up a bit. So let's take this term, this 3x, root 297xy, out to the side and try and break him down. 297 is actually 9 times 33. And the reason that's helpful is we can do the square root of 9. It's a regular 3, but then the rest of this is going to stay in, which is fine because it's going to match up with some other stuff. So 3 comes out and multiplies. This is going to be 9x root 33xy. So let's come back over to our original problem and rewrite it with that first term being simplified. So this first term simplified into 9x root 33xy, and we couldn't simplify the rest, so we're going to leave those be. And then we're looking for things we can put together. So I'm noticing all of the roots match. So my first thought is we're going to be able to put all this together. But then on closer look, do you see how this guy out front is a 9x? This guy is a negative 2x, and this one is a regular old little 8 without an x. So as you know, we can't put x's with guys that don't have x's when we're adding and subtracting. So even though the roots all match, this guy's number out front is not a like term with these guys. But these two are good to go. So let's put those two together. So this guy matches up with this guy. We're going to be able to put them together. I have 9x minus 2x, so that's 7x of those roots. And then I still have this negative 8 of those roots. And unfortunately, that's about all we're going to be able to do with this one, because the front guys are a 7x and a negative 8. I can't put those together, even though the roots match. The front bits have to be like terms as well.